Hey everyone, welcome to the Question Show. Your questions, my answers. As always, wherever you are across my channel, if a question pops in your brain, just write it down. I'll gather them up and I'll answer them here. Now, I do this show live every Monday at 5 p.m. Pacific time. So if you want to join the conversation live and ask your questions, you totally can. And follow-up questions and conversations with the other people who are watching, it's a lot of fun. Now, I got one quick announcement, which is that NASA's Advanced Innovative Concepts program has announced their new set of awards. And there's about 12 stage 1 and I think 5 or 6 stage 2. And I always have such a good time interviewing them. So I've just reached out to pretty much all of them. And so we're going to have a lot of interviews over the next couple of weeks with people that are working on some really interesting ideas, like science fiction, but reality ideas. So I hope you enjoy the interviews. If you skip the interviews, you really shouldn't. They're great. I really enjoy the conversations, great ideas, and you should definitely watch the interviews or like put them on in the background while you're playing some video game or sign up to the podcast. But you should listen to the interviews because that's where the real meat is coming from, where all the really good information is. All right, let's get into the questions. HPA 97. How would it be possible to gather resources from gas giants like Jupiter? Wouldn't the gravity make it near impossible to do anything useful with it? So, I mean, this is like far, far into the future. We've run out of useful hydrogen by splitting up water that's located in the inner solar system, either on Earth or maybe on the moon or in the comets and asteroids. And we still need hydrogen for our hungry fusion reactors. And so the idea is that you send in hydrogen extractors into the atmospheres of Jupiter and Saturn. And how would that be possible? Yeah, I mean, if you tried to go down into the atmosphere of Jupiter and hang around for a while, the gravity well is enormous. Like the surface gravity of Jupiter is about double the surface gravity of the Earth. And so you'd have a really hard time if you brought your spacecraft in and you didn't even land, you're just sort of flying around in the atmosphere, scooping up hydrogen and helium, getting back out of that gravity well. And so the idea that's been proposed is that you would essentially dive in to the atmosphere of Jupiter, skim across the surface, but not lose all your momentum, use your ramjet to pull the hydrogen into the system, use it to ignite the fusion, and then use that to kick you back out once your fuel tanks are full and you go into orbit around Jupiter, and then you, send the hydrogen away, and then you drop in and do it again. So the key is don't slow down. Just keep going. And I guess over long periods of time, the more you do this, the less massive Jupiter becomes, the easier this process gets until you've completely dismantled Jupiter and you've turned it all into fusion energy, which, could take us a while. Crane Army. What does scientific consensus have to do with science? In every context I hear scientific consensus, it seems to intend to indicate some political ethical conclusion that exists disconnected from science and has nothing to do with empirical study or understanding reality. I disagree. I think that when you hear the term scientific consensus, what that means is almost all or the majority of scientists agree on a certain set of facts, observations, conclusions, etc. I think it's really important to understand how science works. Science is not a consensus process. Science is about you take some idea and then scientists try to find anything and everything wrong with that idea that they can. It is the most combative, skeptical environment of knowledge that exists. And it's only when an idea, fails to be disproven does it become accepted by scientists. And so you could take something like the theory of evolution, right? Scientists are beating away on the theory of evolution, every little crack and nook and cranny and corner of it, trying to find anything, any part where it doesn't hold up. Same thing with gravity or relativity or climate science or any of these things. It is driven by this skeptical scientific process. And over time, when you fail to prove it wrong, when you fail to find even just like one example that shows that it's not real, then you have to sort of begrudgingly more and more accept the fact that it could be right, that it's probably right, that the scientific consensus is that it's correct. And, you know, to use some kind of analogy, right? You've got a car that's making a funny sound, and you bring in 10 mechanics who've all worked on this exact model of car, and all the mechanics listen to the sound that the car is making, and 9 of them say there's a problem with the transmission, and 1 of them says, I think there's a problem with the engine. That's the scientific consensus, is that there is probably a problem with the transmission of this car. And obviously, further research would dial in exactly where this problem is, but that's all scientific consensus is. A lot of the times when I hear somebody complaining about the scientific consensus or taking issue with it, it's usually because the scientific consensus is running up against some preconceived notion or political ideology or religious issue or something that they makes them disagree with the scientific consensus. But the scientific way, if you are a scientist or if you appreciate how science works, your job is to then evaluate the data, follow exactly in the footsteps, educate yourself to the point that you understand how this works to as close of a level as you can as the scientist, follow in their footsteps, examine the data. It's usually all out there publicly for anyone to look at. And you can then try to see if you will join the scientific consensus on some matter. And if you don't, if you found some reason why it's wrong, scientists love that. They can't wait to be proven wrong. So either way, you win. Ali, could gravitational waves trigger earthquakes? I guess in theory, right? So you've got gravitational waves come from large amounts of mass moving through space. Like when you're driving, you are generating gravitational waves. There's just not very much of it. It's only when the objects that are moving are incredibly massive, like 2 neutron stars spiraling in and they're about to collide with each other, or you've got 2 black holes colliding with each other, do you get these gravitational waves that propagate out through space to a point that we can even detect them here on Earth. And still, like, the scale of the gravitational waves, the size of them, the change that's happening is incredibly small. It takes just ridiculously sensitive instruments to be able to even detect the most massive events in the universe. You know, a gravitational wave literally is space stretching in one direction and then getting compressed again. Objects, as gravitational waves move through them, they are getting distorted and then put back together again. And so if a gravitational wave was strong enough, then it would sort of squish the Earth and then push the Earth back together again. And you could imagine that would be triggering earthquakes. But you would have to be so close to 2 black holes merging that the gravitational waves cause a serious damage to your planet. And there's lots of other things that are going to cause damage to your planet. All the radiation that's coming out from their merging accretion disks. The tidal forces are exponentially stronger as you are close to these black holes. So earthquakes from the gravitational waves are like the least of your worry at that point. Philip James. Hey Fraser, if a civilization can master fusion, then does this remove the need for a Dyson sphere? Does the sun just inefficiently waste fuel for these mini sun reactors at that point? Could a civilization harvest hydrogen from the star and effectively switch the sun off over time? This would remove the coronal mass ejection issues and make it harder for us to see the civilization from our solar system. Yeah. I mean, like, if a civilization is advanced enough to get to the point where they're starting to build Dyson spheres, where they are trying to enclose their entire sun, they're probably on a pathway to develop the technology of stellar lifting, where you are extracting hydrogen directly off the surface of the sun. You can use magnetic fields. You can try to spin up the sun. There's a few ways that you can try to pull this material off the sun before the sun uses it up. And As you pull material off the sun, you will cause it to go from the main sequence, what is it, a G2 star, you would turn it into a smaller star, like a K star, which actually would have a much longer lifespan. And maybe you could get even smaller and eventually turn it into a red dwarf star. And now you're looking at a star that's going to have billions, trillions of years of lifetime. You could break the sun up into like 13 red dwarf stars. Each one would last trillions of years. So yeah, no, sufficiently advanced civilization would probably do some pretty amazing stuff. And then they would just pull all this material off, and then they would put it into their fusion reactors and store it in blobs of hydrogen that don't undergo fusion, and they can make it last for a significantly longer period of time. So a star is not the most efficient way to use up all of the energy in hydrogen. It just happens to be there and we're using it. But a sufficiently advanced civilization could imagine much more advanced ways to use up that fuel source that's sitting right there. But again, this is like so far into the future, it might as well be magic. Sounds like an Isaac Arthur question. Paul Morgan, could alien civilizations know our history if they've been watching us, like how they built the pyramids? I'm not exactly sure. Are you saying like the aliens built the pyramids? Let's assume they didn't. I mean, there's plenty of evidence that humans built the pyramids, and so, but if aliens are watching us, would they know our history? Sure. Yeah. I mean, if aliens have super advanced technology, they're capable of watching us for long periods of time, and they'd be studying us, they would know a tremendous amount about history. And like, we could ask them who built the pyramids, exactly how it was done. But this idea that we are in some kind of zoo and the aliens are watching us and they are not interacting with us, but they're just watching to make sure that we don't blow ourselves up, or I don't know, we advance to a point where we're allowed to join the Galactic Federation. And, you know, a lot of people give that as an explanation for the Fermi paradox, why we don't see any aliens out there in the universe. I don't really buy that argument because I can't imagine all the aliens behaving exactly the same way and every member of those alien civilizations behaving in exactly the same way. We saw in Star Trek, right? Even though there was the Prime Directive, do not interfere, Kirk was always interfering with the Prime Directive. And so you can imagine that the aliens are going to have their version of Kirk who's going to come down and they're going to violate the Prime Directive. They're going to interact with humanity. They're going to help us with some issue that we get into, and the jig's up. And now we know that there's aliens here. So I don't really believe that we're in a galactic zoo. But aliens, and if aliens are watching us, hello. Scott Bragdon. Any idea when we will get a better picture from James Webb other than 5 dots or a remove before launch sticker? We already got a pretty great image from James Webb this week, which was sort of the next iteration of the focusing process. So they took the 18 mirror segments of James Webb, and you could see 18 versions of the same star. And then they turned them to the point that all of those images converged into one spot. And now they're all working to make one star. But that one star actually isn't in very good focus. So the next thing that they have to do is do a whole other round with all of these telescope mirrors, moving them one at a time, a tiny amount, to the point that they are acting like a single mirror. And they can only make adjustments in tiny little amounts. Like eventually they're moving on the order of dozens of nanometers to get these mirrors aligned up. If I recall, the original estimate was going to take them about 5 to 6 months to get to the point that they could actually do this alignment. So we are 3 months into the process, not even. So we've probably got another 3 months. I would say June is when we'll see the first proper images coming out of James Webb, when it's fully focused. But the cool thing about this process is that NASA's been really transparent. They've shown us the first terrible images, and then they showed us the ones where all of the stars were better, like points, and then they showed the one where they're all focused in. So I wouldn't be surprised if NASA brings us along this entire process as they continue to focus in on this one test star and just make it look sharper and sharper and sharper. So you'll know when James Webb is ready for action. Cinema Australia. What's holding up Starship? Oh, shouldn't we be on Mars by now? Are we going to be on Mars by like 2020? Yeah, 2022. The first humans are going to go to Mars. Maybe it'll be 2024. It's hard, is what's holding up Starship. It's hard and it's complicated. The last big thing that we saw with Starship was the big test where they launched the Starship. It did the belly flop maneuver, landed safely on the launch pad again, and demonstrated that it's going to be able to do a propulsive landing. But from there, they've had to develop a whole bunch of new stuff. They've essentially done a new version of the Raptor engine, the Raptor 2, which is higher thrust, less parts, lighter weight, tends to burn its own chamber up. So they've got a few issues to still work out. They added a heat shield to the rocket so that it can handle coming back through the Earth's atmosphere. They built the launch gantry as well as the capture arms that will grab the Starship and the booster as they're returning to Earth. So there's no landing legs anymore on either of these vehicles, which is brave. And then there are the regulatory issues that they're dealing with from the FAA. And so they have to get to a point where the government is reasonably comfortable that this thing isn't going to be some kind of horrible environmental disaster, cause damage to property, etc. And so I think we should see a full stack launch of Starship at some point in the next couple of months, definitely before the end of 2022. But it's complicated, and each part that they try to improve opens up a hornet's nest of other challenges and issues. So be patient. It's already incredible how far the whole process has gotten. And the next step is this thing goes orbital and hopefully returns safely. It doesn't destroy itself or the launch gantry. Again, brave. Thomas Anfang. If Russia stops supporting the International Space Station in 2024 when their current commitment ends, what happens to the program? Could the ISS continue even with no support from Russia? That's a pretty tricky question. Russia has announced that they aren't planning to maintain the International Space Station beyond the mid-2020s. NASA has said they're probably going to wrap up their support of the space station by 2030. Russia has said they're going to do this in the past many times, and they've always extended their commitment. So if we weren't going through a war right now, I would assume that they would do some negotiations with NASA, align their date of when they're no longer going to support the International Space Station to the same time as NASA, so maybe 2030. But things are very different now over the last week with Russia's invasion of Ukraine. It has caused disruptions to the aerospace industry on multiple fronts. It looks like the ExoMars mission is not going to be able to make it to the launch window because it's a collaboration between Russia and the European Space Agency. You've got American rockets like Antares that use Russian-built engines, which are probably not going to be able to continue. You've got support teams working out of the European Space Agency's launch center in South America that are going home. You've got a whole bunch of commitments that are all now just getting unraveled in real time. I mean, I'm sure the astronauts and the cosmonauts on board the space station are good friends and don't want any kind of war, but the governments are moving backwards to a point where they're not going to be able to get along for a long time. And the whole point of the space station was that it's a trust building process to show that two superpowers that were once enemies can work together for science. And the fact that they can't anymore is sad and troubling. So would ISS continue without support from Russia? The answer is kind of complicated. We don't know. Some of the modules, although were launched by Russia, were actually purchased by the United States. Other parts do need to be supported by Russia. And it's not like you can just sort of break the station apart into a couple of pieces and have them go off in their separate ways. I mean, the parts of the station are doing parts that other parts can't do. So right now, it's just too early. I can't give you any firm answer about what it is. All I know is that every possible outcome right now is worse. Like right now, everything I see is that international collaboration, spaceflight, advancement of science and technology, education is all going to go backwards. And we're going to have a worse outcome than we would have had a couple of weeks ago. And it's heartbreaking. I mean, it's heartbreaking for a million reasons, but it has affected space as well, which really sucks. So here's hoping for a quick resolution and peace. AR West. Hey Fraser, K-type stars last around 70 billion years. M-Dor is 1 trillion or more. How about planets? How long could an Earth analog planet remain habitable around these long-lived stars? Yeah, the K-type star is a star that's a little less massive than the sun, but more massive than a red dwarf. And it's believed that they'll last for about 70 billion years. So while the sun's only going to last for, say, 10 billion years, they'll last 7+ times longer. And they're also not unstable in the way that the red dwarf stars are. So red dwarfs, when they first get going, can be quite troublesome. They can send out really killer flares, but the K-type stars don't do that. And so it's widely considered that actually K-type stars are more habitable than a star like our sun. They produce steady power for a vastly longer period of time, which gives life a chance to evolve into more and more complicated forms if there's life around there. And yeah, planets would orbit around a K-star just fine for billions and billions and billions of years. I mean, the Earth has orbited around the sun for 4.5 billion years and is going to continue to do so for another 5+ billion years. The issue with our sun is that our sun is heating up. Essentially, the hydrogen in the core is being turned into helium. The helium is building up the shell. It's sort of pushing out the size of the sun. It's causing more energy to be released by the sun. And that is causing the temperatures on Earth to go up very slowly. Has nothing to do with climate change. It's going to take 500 million to 1 billion years to get to the point that the Earth is uninhabitable. So the actual habitable period of the Earth is only about 500 million to 1 billion years from now. While, say, that same process would be happening with a K-star, but it's going to take vastly longer. And so you can imagine a planet being in a nice habitable time period for 50 billion years. So yeah, I would much rather be orbiting around a K-star than the sun, but we don't get to make these kinds of choices sometimes. It's like choosing your parents. More questions in a second, but first I'd like to thank our patrons. Shiny Latios, Dawn Stalter, Jill Clancy, Cat, Umina Shaka Cat, My Cat Mr. Clean. Cat related. And the rest of our 827 patrons for their generous support. Want our videos early with no ads? Join our community at patreon.com/universetoday. Dima R. I was wondering if there's any public companies where I can invest in space mining. I don't know if there's any public companies anymore, but there's been a few private companies that have been created to try and do space mining, and they all go out of business. It's a notoriously difficult industry to try to get into because rockets are expensive, because asteroids are difficult to reach, because the technology is complicated and expensive, and it requires enormous and long periods of time of engineering, and Earth has lots of minerals on it. And so why go and try to mine from an asteroid when you can mine down here on Earth? In the far future, there will be all kinds of space infrastructure that's going to require space resources, and then it makes total sense to mine them from asteroids. But I think that we are like 100 years too early to be talking about asteroid mining, like a mining company that's going to try to make a profit. So I would wait if I were you. Pim Sheffers. How do they locate where the gravitational waves come from? Triangulation. So right now there are the 2 LIGO observatories, and then there's an observatory in Europe, and then the Japanese are developing an observatory as well. So what happens is, say you have some event, some 2 black holes collide with each other, the gravitational waves sweep past planet Earth, they strike one sensor first, then they strike another sensor next, and then they strike a third sensor. And once you've got those 3 sensors getting hit by the gravitational wave, you're able to then triangulate the position. So before you had that third sensor that was in Europe, you only had the 2 sensors from LIGO. And the problem was then they could only know which hemisphere of the sky the gravitational waves were coming from. But once you get that third, you know precisely to within a very small area. And then when you get the 4th one, then it's even better. And eventually there's going to be a dozen gravitational wave observatories on Earth. There'll be ones in space. We will know precisely where these collisions are happening. Ted Krause. Could our solar system, our sun and planets, break away from the Milky Way and survive intact without the Milky Way? So I guess you're asking, like, could the sun with the planets go rogue through something and leave the Milky Way and be fine. So there's kind of two parts to this question. The first part is like, what would be the event that would cause the sun to leave the Milky Way? Because the escape velocity of the Milky Way is fast. It's like above 500 kilometers per second. So you need some really extreme event, like a really close call with a supermassive black hole at the middle of the Milky Way, or you're in a binary system and your companion star explodes as a supernova, and then you're flung out of the Milky Way. So you would need some really colossal event. And if that happened, the sun, the planets would be ruined. The shattered remnants of the sun might be flying out of the Milky Way, but it's not the sun you knew, and the planets are destroyed. So let's imagine instead that we built some really powerful thruster that we had somehow attached to the sun. We built a scat-off thruster, so we let the sun's own energy push it around inside the Milky Way, and it gets faster and faster and faster and leaves the Milky Way. And so now you're outside of the Milky Way with the sun and the planets. Is there any change? Maybe. One of the theories for some of the great extinctions that have happened in the past is that there is essentially cosmic radiation that's coming from across the universe. And the Milky Way has a collective magnetosphere, has this interstellar medium, has particles that diffuse and deflect and decrease the damage from that radiation. And so if you were outside of the Milky Way, you would no longer be protected by the rest of the Milky Way, and you would experience more of that radiation. But I don't think it would overcome what the Earth's magnetosphere would be able to handle, but maybe. I mean, like I said, some astronomers have considered this as a possible cause for extinctions in the past, that the sun rose up above the plane of the Milky Way, was less protected by the particles coming at it, and took a bunch of damage before it sort of sunk back into the rest of the Milky Way and then went down below the Milky Way's disk, experienced more. Like when that happened in the past kind of lines up with some extinction events. So if that's true and we did leave the Milky Way, then maybe we'd be more at risk to some of this cosmic radiation, but maybe not. So let's not find out. Slaughterbartfest. Are we von Neumann probes? Like, are we human beings von Neumann probes? Is life a von Neumann probe? I would say that life, like if you were developing von Neumann probes, so von Neumann probes, of course, are this idea of self-replicating spaceships that are going to travel across the entire Milky Way, go from star to star, build more copies of themselves, go on to other places. So, like, if you wanted to fully colonize every nook and cranny of planet Earth, yeah, you would breed up a bunch of tardigrades and turn them loose and let them do their tardigrade thing. And eventually you come back 1,000,000 years later and there's tardigrades everywhere. But tardigrades are really bad at building spaceships and going to other star systems. While we as human beings, we're not great at it, but in theory we can do it. But then like we're going to build the robots and it's going to be the robots that do it. So we're like the factories. We're the factories for the robots to build more robots. But I don't think we're the von Neumann probes. UK man loves goddesses. I'm a bit skeptical because when the booster rockets come back down to land, the camera usually stops working as if it crashed maybe, and then they show a booster on a boat, but it's really the same boat. So you're suggesting that SpaceX rockets don't actually land? But where did the rocket come from? Like when there's a boat that's coming back into port and it's got a rocket on it and it's covered in soot, like did it come from a rocket factory in the ocean? And where do the rockets go when they don't have enough fuel to get to orbit? Are they crashing into the ocean? Like remember the Falcon Heavy, and you could see the Falcon Heavy, 2 boosters landed perfectly side by side, no cutoff of the camera. Yeah, when you have a rocket coming down to your drone ship, blasting energy, it can be a little rough on a camera and your camera needs to go down for a little while. But there's been plenty of landings where they've watched it the whole time. Yeah, I would not be skeptical that SpaceX is reusing rockets. I would believe it. James McClellan. G'day from Australia. Was wondering why more rover-type missions don't focus on ice areas on Mars or the Moon. There have been some rovers that have gone to some of the more icy areas of Mars and the Moon. There was the Mars Phoenix mission, which was sent by NASA to the North Pole of Mars, and its job was to scoop into the regolith looking for water ice mixed in with the regolith. The Chinese have their Chang'e missions, Chang'e 5, which is on the far side of the Moon, near the Moon's south pole, looking for water ice. There's going to be a whole bunch of new missions coming very shortly. NASA's next big rover to the Moon is going straight towards the icy regions. So I think over the coming years, the Chinese are doubling down. They're going to be sending more. I think we're going to see a ton of more spacecraft going to the icy regions of the Moon and Mars. Like, we've only really known that these places are there for the last 10 years or so. And so it just takes time for the scientific consensus to agree that these are good places for us to study, to build up mission concepts, to send them, to extract the data, etc. So stay tuned. There's going to be a lot of really cool things coming. Moochie to Cat. Is James Webb Space Telescope getting solar power at L2? Isn't it fully in shade of the Earth from the sun? No. James Webb isn't in shade from the Earth. It just has the Earth, the sun, and the Moon in a very tight region in the sky. But because it's so far away, like 1.5 million kilometers, the chances of the sun, the Earth, the Moon aligning up perfectly so that James Webb is in shadow is incredibly remote and rare. And in fact, even if the Earth passed right in front of the sun, it wouldn't block the entire sun. So no, James Webb has solar panels on the bottom of it that it uses to harness power nonstop from the sun. And then the sunshade creates the shadow that the telescope is inside. So it's not from the Earth, it's from the sunshade that's doing the heavy lifting. Chippy726. Do you think they could use ISS for something else instead of crashing it into the Pacific? So the big problem with the International Space Station is that it's getting old and it's getting more wear and tear, requiring more maintenance, and it gets harder and harder to keep it doing its job. It's a machine, and the machine is 23 years old now, has been running in space, and they're planning to keep it running for another 9 years. It's going to be 30 years old. Imagine like a 30-year-old machine, but in space without a lot of tools and support and maintenance, except for what the astronauts can do. It's just getting old. So there are some ideas. One idea is that private companies are going to be adding segments onto the space station. And then when the time comes to deorbit the International Space Station, they're going to detach those segments, and maybe they could include some other parts to them as well as they detach them and boost their orbits before they bring down the rest of the station. You know, a lot of people think it's inexpensive and easy to boost the space station, and it's possible, but you would definitely need to put a lot of fuel, a lot of propellant to raise it into a higher orbit. And at a certain point, really important critical parts of this machine are going to wear down and break down and risk the lives of the astronauts. So NASA is continuously looking at the state of the space station, and this is why they're making this choice about when it's time to wrap it up and deorbit the space station. It's gone vastly longer than anyone's ever expecting. It's done a ton of science. It's old. It's probably time to bring it down in 10 more years. Michael Floyd, hello from McMurdo Station, Antarctica. Our question is, do neutron stars have a solid crust? And if so, do we know their estimated thickness? That is awesome. I have never had a live question from Antarctica that I know of. So neutron stars they have layers. They're like ogres and onions. The outer layer is kind of like an atmosphere. It's like a haze of electrons and protons. As you go inside, you get a mix of protons and electrons mixed in with neutrons. And eventually you've got more packed in neutrons you get down. But the sizes of these layers are very small. I mean, if the whole thing is, say, 10 kilometers across, then the layers are, in some cases, sub-kilometer across. Would they have a solid crust? Yeah, I mean, obviously, if you tried to stand on a neutron star, the intense gravity would turn you into just a mist. You'd be added in a 1 atom thick layer to the outside of the neutron star. But it would be solid if you could somehow, if you were made of black holes, or I don't know, if you're made of diamonds, incredibly tough, hard. which you would have to be to work in Antarctica. Sunlight. Is there still any hope for the LUVOIR telescope being built anytime soon? As far as I heard, it was recommended that they fund a smaller telescope. You heard correctly. So the LUVOIR telescope, which we've talked a lot about, was thought to be like a 9-meter, a 15-meter follow-on telescope from Hubble. So imagine a telescope that was much bigger than James Webb and would have a similar sun shield. It would work in infrared, ultraviolet, visible light. It would be able to do some incredible things. But in the most recent decadal survey, which was the recommendations from the space science community, they recommended against going with LUVOIR and instead going with a James Webb class telescope with infrared, optical, ultraviolet, and maybe have a sun shield as well that would be able to block the light and help allow it to reveal planets. So chances are we're not going to get a LUVOIR, and definitely not as big a telescope as expected, but who knows what's going to happen with Starship. Starship could change the game on everything, that it could make gigantic telescopes totally feasible again with its 9-meter launch fairing. It's almost double the size of a launch fairing of a traditional rocket. So you could make a much bigger telescope. You could put a James Webb inside Starship and not have to have anything folded up. It would just sit as a 9-meter or 8.5-meter telescope inside Starship. So stay tuned. Starship may change everything, and they'll have to rewrite all of their plans. Like if I was working at NASA, working on really any proposal, I would be providing my traditional suggestions on how this mission is going to go, but I would also add but if Starship exists clause and go, here's how we should change everything, because we could be just a couple of years away from Starship arriving and being capable of launching these much larger missions for a fraction of the price. And if you're developing a spacecraft to fit inside the launch fairing of an Ariane rocket or an Atlas, and now you've got this much larger launch fairing and weight capacity, it will totally change the way you consider your mission. So who knows? Who knows? But right now, the plan is no, not LUVOIR as we understand it. Jeff Wilkie, would a diamond spaghettify entering a black hole? I don't know the answer for sure. So I guess the question is if you fell into a black hole, as you got closer and closer, the tidal forces of the black hole would tear you apart into two pieces, and then the two pieces would be torn apart, and then you just eventually end up as this single atom width stream that would get wrapped around the black hole. And so would the same thing happen to a diamond? It just depends on the size of the black hole, the event horizon of the black hole. If you have a supermassive black hole, you could fly in your spaceship through the event horizon of the black hole. It'd be very smooth. You wouldn't feel the tidal forces. You wouldn't even know that you passed the event horizon, but now you're stuck inside the black hole. Well, if you were getting really close to a stellar mass black hole, the tidal forces would be extreme and you would be torn apart in that horrible spaghettification way. And then would a diamond? Depends on the size of the diamond, but I would expect, that there is a Roche limit, a point at which you get close enough to a black hole that even a diamond will be torn apart into its component pieces. Depends on the size of the black hole. And the math for that is beyond me. Just a journalist, not an astronomer. Phil Gillette, how important do you think it is for the habitability of a terrestrial planet to have a Jupiter analog in other solar systems? So I guess you're asking, does Earth require a Jupiter to be habitable? And I think the answer is no. Now, there's a lot of people say that Jupiter protects us from asteroid impacts and comet impacts because of its gravity. It's siphoning up all of this material that would fall into the Earth. And that's possible. It definitely does shift some of this material away, but it also throws stuff at us. So really the jury is out on whether Jupiter is a help or a harm. But the constant harm that Jupiter is doing is that through its gravitational interaction, it is shifting asteroids out of the asteroid belt and pushing them down into the inner solar system. And pretty much all of the near-Earth asteroids that we have today were all caused by Jupiter in the last few million years. It's near-Earth asteroids, they don't last long. They end up in the sun, they crash into planets, or they get kicked out of the area. And that's all because of Jupiter's gravity pushing them in. So if we didn't have Jupiter, then we wouldn't have near-Earth asteroids or as many near-Earth asteroids. So you could argue that it would be safer for us. So no, I don't think you need to have a Jupiter analog in some other star system for a habitable planet. If anything, removing planets makes your solar system more stable, less gravitational interactions. Damien Reloaded. If Earth became uninhabitable, do you believe mankind continue to live on by wearing spacesuits forever? So, no. The Earth is doing so much work for us right now. It is providing us warm temperature. It's providing us air to breathe. It's providing us clean water. It's providing us stable ground to stand on, gravity. It's got all these plants and animals and stuff growing on it. It has a magnetosphere that protects us from radiation. Like, the list goes on and on and on about how much of our existence is just dependent on the fact that the Earth is so great. And so if you didn't have access to all of those resources, if you had to use your own engineering to mitigate all of them, or as many of them as, so say the temperature was awful, too cold, too hot, so you'd have to wear a spacesuit, that the atmosphere was unbreathable, so you would have to generate your own oxygen, that the radiation was brutal, and so you couldn't go outside for long periods of time. You have to stay inside. Without an enormous amount of technology, we wouldn't stand a chance. People are struggling to get by already in various parts of the Earth, living below the poverty line, because they're having a hard time getting enough resources from this planet, which is giving us so much. There's lots of reasons why people are in poverty. But what you're describing is living on Mars. Like, that's Mars. Mars has a terrible atmosphere. Mars is brutally cold. Mars has deadly radiation. Mars doesn't have plants. It doesn't have readily available water that just falls down on you and you drink it. So you're going to have to solve all of those problems purely with engineering. And, I've heard estimates it's going to take 1 million people living on Mars with advanced technology to just not die. So no, if we lost more of what makes Earth so great, we wouldn't be able to survive in our current form. Maybe a few people with advanced technology living underground could eke out life for a while, but no, we need the Earth badly. And so it kind of sucks that we're making it worse for us, as well as for all the animals and species that live with us. All right. Those were all the questions that we had this week. Thank you, everyone, for asking questions in the comments or showing up for the live show. Super fun. And we will see you next week. If you want a single comprehensive resource for space news, you'll want to subscribe to my weekly email newsletter. Every Friday, I send out a magazine of space news with dozens of stories, pictures, brief highlights, and links so that you can find out more. Go to universetoday.com/newsletter to sign up. It's totally free. And did you know that all my videos are also available in a handy audio podcast format so that you can have the latest episodes as well as special bonus material like interviews with me show up on your audio device? Go to universetoday.com/audio or search for Universe Today on iTunes, Spotify, or wherever you get your podcasts. And I'll put a link in the show notes. Thanks to all the moderators, and a special thanks as always to Chad Weber and Nancy Graziano.